I want to look at the properties of gravitational potential energy. Again, I could literally come up here and I could look at this statement up here. Look at this statement right here. And I'm just going to copy this, but I'm going to rewrite it. This is exactly the same. This is true for all energies. And I'm just going to paste it here, but then I'm going to erase it immediately. But look what I'm going to say. I'm going to say the exact same thing. Only changes in gravitational potential energy are meaningful. I just wanted to show you that it means the exact same thing. It's just slightly different. So when I talk about work, that work then is the change in gravitational potential energy. Whereas if I look at just gravitational potential energy at a single point, is meaningless. Okay? So when you look at this thing, look what I'm saying. I'm saying the exact same thing, right? Meaningful, meaningless. Only changes, and that's because of work. It's the definition of work. So what we see here is that gravitational potential energy depends on work and height. Oops, no, not work, but weight and height. So note, we already did the height thing here, but we're going to do it again just to be really careful here. So let's look at this thing here. So picture-wise, I got to compare two situations. So now what I'm going to do here is I'm going to look at height It looks like we may have already done this, but I'm going to say we have not, because we were talking about the amount of work. So here I go. Okay. So what do I got to do? I got to compare two situations. Okay, so I need to compare two situations. So the first one should look something like this. So if I have a surface here, what I'm going to do here is that I'm going to do what? I'm going to lift the boxes. And I think I'm going to have to move one of these. I think I am going to move this over because I think I'm going to run out of space. And what am I doing? I'm lifting boxes. So what I'm going to do here is I'm going to lift this box. And then what I'm going to do here is that I'm going to lift this box. I want to compare the red, the green and the blue boxes here. So if I lift up this box, not because it's a single box, I'm only lifting it to be right here. So what did I do here? Well, I had to lift up this box, so I had to apply a force. As a consequence, I only moved it this height right here. Okay. And what I'm going to do here is I'm going to say that down here, D is equal to 0. That means that the height there is 0. Now what I'm going to do is that I'm going to lift this other box. This time, I'm going to move at what? This height. So if you had to lift the box much higher, you know that's got to take more work. So even though I'm applying the exact same force, I should be saying the force of gravity because you're lifting up the weight of the box. What you're seeing here is that this height is clearly larger. So again, the box starts off at 0. So when I look at this thing, what do we say? Well, for starters here, you can see here is that this guy right here starts at a potential energy of 0 because there's no height. And then as I lift this up, this gets some gravitational potential energy right there. Now, if you look at this other situation, we can clearly see here that this gravitational potential energy is 0. Why? Because it starts at 0 height. It's only changes in height. But if I look at this in terms of work, clearly the one that you lifted up higher must have what? Bigger gravitational potential energy. So now I start drawing my equations here. So if I look at this guy, we could see that we have this amount of gravitational potential. And then I went to 0. This one, on the other hand, had a bigger gravitational potential and went to 0. So when I'm looking at this thing, we ask the question, why did this one have a smaller change in gravitational potential? Well, in this case, they're both the same force of gravity, but the big difference is that this is a little d and this is a bigger d. That's what made the gravitational potential bigger. And then, of course, the change is from 0. So therefore, this guy has a smaller change in gravitational potential. So therefore, that required what? It required less work. On this other hand, this guy was what? It has a large gravitational potential energy. And as a consequence, it took more work. So, right, remember? Less stored work. More stored work. So if I look at this in my bar diagrams, look at my bar diagrams. What does it say here? Well, what it says here is it says the following thing here. Is it says this, I did work. How much work did you do? Well, I only did, let's say, this amount of work, right? I only did this amount of work. So when I look at that work, it's that big. But if I look over here, I did more work. And where was the potential energy initially? Well, the gravitational potential was 0. Here, the gravitational potential was 0. There's no energy when it's on the ground. I didn't do any work. But now, according to the work energy theorem, the work does not disappear. It reappears as energy. So when I look at this guy, all of that work got transferred in a gravitational potential. So I'm going from work to energy. Whereas in this case here, this work was bigger. I stored more work in here. And that's why we have that. Right? That's what we mean by that bar diagram. The same thing happens when I go in and I look at the weight dependence. If I look at the weight dependence, you know which requires more work, right? You know which requires more work. So in this case here, we're going to compare two situations again involving weight. So here I go. So imagine that I have this here. And if I have this, what we're going to do here is that now I have a weight scale, not a weight scale, but a lift station. And what I'm going to do is that I'm going to lift these cars up to the same height, right? I'm going to lift these to the same height. So then we got to get real specific. What do I mean by the same height? Well, in this situation, I have a small car. Right? So here's my car right here. And then in this situation, I have a big truck. And when I look at this truck, we could see that the truck is heavier than the car. So now if I lift this car, which even though I'm going to the same height here, right? I'm going to this height. I'm going to this height. But again, that height in this case starts at 0. So when I look at this car and I ask the question, which requires more work? Well, clearly the truck requires more work to lift this. Right? Clearly it requires more work. So when I look at this and I compare them, I then go like, yep, this required less work. This required more work. What do I mean by that? Well, work is what? This has to do with change in gravitational potential energy. If I have a smaller work, I have a smaller gravitational potential energy. And then this guy becomes a larger change in potential energy. So the question is, why? Why is there a difference? Well, to lift this one takes only a small force compared to this guy that takes a big force because they weigh different. So when I look at this guy, it's got to look like this. This has a small force of gravity. This has a large force of gravity. Even though the distances are the same, when I change this, that is the reason that that happens here. So in this case, we could draw another kind of diagram that looks something like this. I did work. How much work did I do? Well, in this case, I only did that amount of work. On the other hand, I clearly did more work. So where did all that work go to? It went into what? Changing the potential energy. Right? That's what changed the potential energy of the car. This is what changed the potential energy of the truck. And it took a lot more work, so therefore a lot more got stored.